Griffin's Occasional Series YouTube tutorials. Today we're in Excel doing first order differential equations using Euler's method. We want to solve that using the initial condition there. So the instructions are there on the left hand side. I'll just scroll down a little bit so you can see just leave it about there. So let's look at this here. So 0, these are the x values, so and then the x value is the previous value plus plus 0.2, so it's just up there. A5 plus c dot r2, so A5 is the previous one plus 0.2, and then when you drag down that will be A6 plus C2, so we're going up in steps of 0.2. How do we get this value here? That's the initial value. Where do we get that from? There, it's 1. Now we have to get, the f of the Euler approximation to the thing. So the Euler approximation is, just scroll up there ever so slightly there, and we get the new one. So the new value is b5, which is y, which is just there, plus a5 squared, which is x squared. So that gives us that. Don't worry about column D. Next thing here, the x value is 0.2. Now we have to get the new y value, and the new y value is the y old. Y old is just above it there in B5, and the h, that's the step size, 0.2 of the f of x old y old, and the f of x old y old C5 there. So it's that guy by the previous value. So that will give me the new y, and the new Euler is B5. How do we know it's B5? Well, sorry, it's B6 in this case. It's B6 in this case, plus A6 squared. So it's that one plus that one, and that'll give me the new Euler approximation. We carry on, and we get the values there. Now the real solution, which you could solve by hand, is somewhere, just find it now a sec. The real solution is there. So you could integrate that by hand. We've banged that in there, just give you a chance to see the formula up there. So there's the real solution. We dragged that down to get the real ones, and then we did a graph, and we plotted the real solution is in red, and the approximate solution is in Euler. And you can see as time goes on, the Euler approximation, the error gets worse and worse. Hope that helps a little, and thanks very much for listening.